The tabular method can be extended when we are trying to find the center of mass of a non-homogeneous body. In this case, the centroid and the center of mass are going to be two different locations. So we'll be able to start off with the basic table like we had before, and we're going to still be partitioning our shape into subshapes. The first constraint when we are dealing with a non-homogeneous body, though, is that every subshape has to have one material associated with it, whether it's a positive shape or a negative shape. And then what we can do is extend the table by adding more columns to our calculations. So for example here, if we're dealing with a 3D body, we're going to break our total body into its subshapes, 3D subshapes that have only one material associated with it. And then for each of those partitioned shapes, we're going to calculate the volume. If this were 2D, we could do this with area, would be the same idea. So what's new when we're dealing with the non-homogeneous bodies is for every partitioned shape, we need to put in here what its density is. In the case of 3D shapes, we are going to use the volumetric density. And if we were dealing with areas, we would be using the density per square area. And then what we're going to do with that, that's a new step, is we want to calculate the mass of each of our partitioned shapes, which is going to be the volume times the volumetric density, or the area times the density per square area in 2D. And now the mass is going to be what we are calculating for each partition shape and then adding up to find its total. Then for each of the shapes, we are, as normal, going to find its centroidal location relative to the origin of our system. In this case, we have our x, y, and z tilde. Then for our products, we're going to be multiplying the mass of the shape times the location of the centroid in the x, the y, and the z. Then when we are going to be summing down our columns, we are going to be summing our mx tildes, my tildes, and mz tildes. And then when we want to find the center of mass, the x bar, y bar, z bar, it's going to be the sum of the mx tildes over the sum of m. The y bar is the my tildes over m, and the z bar is going to be the sum of the mz tildes over m. So the m is the total mass of our object is going to act as the divisor for the x bar, the y bar, and the z bar. Now, this is unnecessary when we have a homogeneous body because every shape is going to have the exact same density. So the mass is just going to be a scaled multiple of the volume or the area that we're dealing with. So that's why this step is unnecessary for homogeneous bodies, but for non-homogeneous bodies where the densities are going to differ between all of the shapes, that's why we're going to add this extra step.